Okay, so today I am actually going to be seeding some human adipocytes, ADMSCs. And so I'm seeding these to differentiate them. It takes about 28 to 30 days to fully differentiate these from pre-adipocytes to mature adipocytes, so that I can do some experiments with those for my second project. And then I'm going to be collecting some Wnt3A and R-spine media. I'm going to split them so I can grow up some more media. And then I should be done with that portion of the organoid experiment so that I can actually start to make the organoid media and then start the extraction of the cells from the PDXs. So guys, that's actually my insulin pump going off. So yeah, so let's get to it. Okay, so I have my ADMSCs out. I'm going to start with those. And so basically, I just have the, I'm looking under the microscope to see how confluent they are. I'm going to change this to camera view and see if we can go ahead and pull up an image of these cells. I have to get them into focus here. There they are. They're beautiful. Okay, so these are the ADMSCs. They're pre-adipocytes right now. So they're kind of elongated. When they turn into adipocytes, which are fat cells, they'll become more circular like a fat cell. And so hopefully you'll get to see that in one of my videos 28 to 30 days from now. But yeah, we're pretty much here now. So the cells look great. They look confluent. So I'm about to take these out. I'm going to put them into some smaller flasks. And the way I do that is through trypsinizing these cells. So we use a 0.25% trypsin reagent to detach the cells from the flask. I'm going to incubate those for 3 to 5 minutes. Then once they detach, I'll actually do a cell count. And then we will go ahead and move forward with seeding them to get prepped for differentiation. So they have to sit for 2 days before we start the differentiation process. Let's do it. Okay, so I've added about 3 ml of trypsin into the flask. As you can see, I have to make sure this is kind of uniform. We're going to put it in for about 2 to 3 minutes. Sorry about the camera hold. And so we'll put that in for about 2 to 3 minutes, and I'll show you how this kind of looks under the scope once they're detached. So as you can see, most of the cells are now detached. You can tell because they're moving around in there. They're more circular. They're not on the bottom of the flask. They're floating. That's what they're supposed to do. There's still quite a few on the bottom of the flask, so I'm going to incubate this just a little bit longer, and then I'm going to test or look at the cell count so I can determine how many cells that I need to see that my cell density. Okay, so now we're moving on to determining the cell concentration that's within the sample. I seeded some of my cells here in this slide. You can't see them yet, but we're going to use the Nextlam cell counter, which is just an automated cell counter here. So basically, I place some of the slides here, and I'm going to ask it to count what I have, and then once it counts what I have, I can determine how much of the original cell sample I need to get the density that I want in each of my plates. So that's basically what I'm doing, and yeah, I'll hit count and it'll tell me how much I have here. Woohoo! So basically what it did here, I told it what the total concentration was. It's actually my original sample value, which is actually 10 ml, not 5. So I'm going to change that. I want 20,000 cells per plate, and so it's telling me in order to get the 20,000 cells per plate, I need to add 135.98 microliters of the sample. It tells me how many aliquots it's good for. I don't need all of those, but I'm going to basically add this amount of the original cell sample to each plate. I'm going to add about 3 mils of my media, and then that'll give me what I need. Okay, so the other thing we were doing today was collecting the Win3A and mass spinal media that I had my recent previous video. And we're going to do this for vacuum filtration, so I'll show you how that's done. So basically, I took all the media from this that were incubating with these Win3A cells, one cells, out there, and I took the Win3A media, I put it in this vacuum filter system, and so it's going to filter through a 0.22 micron filter, and then from there it will collect all the media. So we are going to start there. Once the vacuum comes on, everything goes to the bottom, drips to the bottom. It's pretty thick, and we'll keep collecting this media until we get enough.